Hi everyone, this is lesson 25A. It is section 7.4 in your textbook, and it is called the reciprocal of a function, part 1. Okay, so part 1 is going to talk about reciprocals of linear functions. We're going to wait until you guys have done quadratic functions to do part 2, which of course will be the reciprocal of quadratic functions. Anyways, a reciprocal function is a special case of a rational function. Remember, a rational function was a polynomial fraction, so it had a numerator and denominator. Okay? For a reciprocal function, the numerator will always be 1, and it's going to take the form y equals 1 over f of x. Okay, remember f of x is just a function. Okay? So, where f of x is some kind of a polynomial, and remember f of x can't be 0. Remember, you are never allowed to divide by 0. So, in keeping with that, this f of x bit cannot be 0 ever. Awesome. Okay, so you'll recall that the reciprocal of a number is simply obtained by interchanging the numerator and denominator. They just flip. Okay, so the 3 goes down to the bottom, okay, and the 4 goes up to the top. So the numerator and denominator flip. So if you have just a single variable, okay, x, or even a single number, it's not a big deal, because remember, we can write x as a fraction, x over 1, right? So when you flip those, okay, the reciprocal becomes 1 over x, okay? Likewise, if we have some function f of x, okay, the reciprocal of that is just 1 over f of x. Now remember, f of x can't equal 0. Here, we should have written this way, x cannot equal 0 either. Okay, remember, we're never allowed to equal 0. Perfect. Okay, so some things that I want you to consider or that will help when you are dealing with reciprocals. So the reciprocal of 1 is, well, if you look at 1, well, 1 is 1 over 1. And if you flip those, well, wait a second, that's going to be 1 over 1 again. So the reciprocal of 1 is just 1. Okay, the reciprocal of negative 1, if we do the same logic, negative 1 divided by 1, and then flip them, then we get 1 over negative 1. Wait a sec, 1 divided by negative 1 is still negative 1. Whoa, that's crazy. So the reciprocal of 1 is 1. The reciprocal of negative 1 is negative 1. Well, that's pretty cool. Those ones stay the same. Now the reciprocal of 0. So if I take 0, go 0 over 1, and then try and flip it. Okay, so that's going to be 1 over 0. Hey, wait a second. You're never allowed to divide by 0 ever. Okay, so this is undefined, or 0 with a line through it. So we'll write it out undefined. Perfect. Okay. Now, the product of a number and its reciprocal is equal to what? Now, you might have learned this in previous math courses, but let's just play a game and try it. So up here, it said that 3/4 had the reciprocal of 4/3. So if we multiply those two together, okay, now we can go top times tops, bottoms times bottoms and get 12 divided by 12, okay, which equals 1. Or we could have went and crossed off the diagonals, 1, 1, 1, 1, and 1 times 1 divided by 1 times 1, well, hey, that's just 1 as well. So either way you decide to multiply those, or you could just type it into your calculator, but either way you do it, the product of a number and its reciprocal is always 1. That's the way these things work. Interesting. Okay, taking the reciprocal of a negative number results in a what kind of number? Well, if we go negative 3 divided by 1, okay, now if we take the reciprocal of that, that's going to be 1 over negative 3. Now, we usually don't leave the negative on the bottom. We write it out in front or on top, so negative 1/3. So if I take the negative or the reciprocal of a negative number, I'm going to end up with a negative number. If I take the reciprocal of a positive number, well, I'm going to get the get another positive number. Negative number, positive number. Now consider the sequence 1, 10, 100, 1,000. As this sequence increases, so as these numbers get bigger, what happens to the reciprocal? Okay. Well, this first one, I get 1 over 1, which is just 1. Okay, then I get 1 over 10. Then I get 1 over 100. Then I get 1 over 1,000, etc. Okay, so the numbers, the reciprocal, is getting smaller. Okay, so as the sequence gets bigger, the reciprocal gets smaller. So it gets smaller. Wow, that's terrible writing. I'm so sorry. It gets smaller or closer to 0. Okay, so in general, I want to make a point about number 7. In general, if you take like a very large number and take the reciprocal of it, so if we go 1 divided by big, if we have a really big number and I take the reciprocal of it, 1 divided by big is very small. Okay, and likewise, 1 divided by something really small is very big. Okay, now 1 divided by 1,000, I think we can all agree that that's really small, or very small. Now, we didn't really do an example of the 1 divided by small, so let's say that, okay, let's say x is 0.00001. Let's just say. Okay, so that I think we can agree that this is very small. Okay, so if I go 1 divided by that, 0.00001, 4 zeros and a 1, okay, I'll get my trusty calculator out. 1 divided by 0.1234 zeros and a 1. Hey, wait a second. That's like 100,000. Holy moly, like that is very big. So, in general, 1 divided by big, very small. 1 divided by small is very big. Awesome. Moving on. Okay, so the graph of a reciprocal function can be graphed on your graphing calculator. Okay, if you have a TI-84, it's y equals x and y equals 1 over x. If you have a TI-Inspire, okay, remember TI-Inspire's graph f of x's. Okay, so f of x would equal x, okay, and then f of x would equal 1 over f of x. Okay, fair enough. Nope. Sorry, I guess it'd be 1 over x. All good. Okay, fantastic. Now, I want to talk a little bit about that. Remember, the way I teach this, okay, so y and f of x, those are the same things. They're replaceable. So basically, what this is talking about is if y equals f of x, okay, then f of x, okay, so 1 over x, if that's f of x, okay, the idea here is the y values. So if this is y equals 1 over x, so what's going to end up happening is that the y values are going to be reciprocaled, if you will. Okay, so if you look at this picture, okay, so here's the graph of y equals x. Okay, if y equals x, then when x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. When x is negative 1, y is negative 1. When x is 2, y is 2. Okay, when x is 0, y is 0. That's an important point right there. Okay, so the domain of the first one, y equals x, okay, the domain is everything. This line is going to go on forever. So we say that as x is an element of the reals. Okay, the range, it's going to go up forever and down forever, so we say y is an element of the reals. All right, so for this reciprocal graph, now we haven't explained anything on why you've done this, okay, nothing real anyways. This is just what your calculator graphs when you graph it, 1 over x. Hopefully you tried that on your calculator. Okay. Now, on TI-84s, it actually does something a little bit weirder. Okay. It looks like this. It actually draws this line kind of thicker for you. It does that. At least it does on some operating systems. So it almost looks like it's connected here. Okay, we'll get into that in a minute. But don't stress over it. Okay, the idea here though is this line here gets closer and closer and closer to the y-axis and never touches. Okay, so the domain is everything except when x is 0. So x is an element of the reals except x is not equal to 0. And then the same thing happens along the the x-axis, which of course is y equals 0. Okay, so y is also an element of the reals, but y cannot equal 0. Interesting. You're probably thinking, oh, what's going on with that? Okay, one very important feature of the reciprocal graph is the presence of asymptotes. Okay, asymptotes is what that's called. Okay, an asymptote is a line that the graph gets closer and closer and closer to, but never touches. Okay, in the reciprocal graph above, there are two. The x-axis is called a horizontal asymptote because, of course, it's a horizontal line. Okay, and the y-axis, in this case, serves as the vertical asymptote. That's interesting. Okay, tell you what, if I draw in red here for a second. Okay, so this line here, that's the vertical asymptote. And my graph gets closer and closer and closer to it, but never touches. The horizontal asymptote is the x-axis. Okay, that of course is the line y equals 0. Okay, and our line, our graph here gets closer and closer and closer to that. Okay, remember 1 divided by very big is very small. So as we get out here to say x is 10 or x is 100 or x is 1,000, okay, this graph is going to be 1 over 10 or 1 over 100 or 1 over 1,000. See, the numbers get very close to 0. They get very, very small, but they are never 0. Like even 1 over 1,000,000, it's really small, but it's bigger than 0. Okay, that's why it kind of rides this asymptote. It gets closer and closer and closer to it, but never touches. Up here, see the y values are getting really, 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 really big. Okay, so if we go 1 divided by that, our x values get really, really, really small, but hey, they're still positive x values. So they're bigger than 0. Okay, but very, very small. All right, we'll talk more about that in a bit. Okay. So the reciprocal graph on the previous page had both of its axes as asymptotes, both the x and the y axes, okay, as asymptotes, but that is not always the way it is. So I want you to have just a quick look at this mythical graph I made up. Okay, it looks like this, it goes like that. So there's a horizontal asymptote, and it goes along here. Okay, I didn't give you numbers for it, but let's say that's 1, 2, 3, 4, let's say. Okay, so the horizontal asymptote here would be y equals 4. Okay, and the vertical asymptote, let's say 1, 2. Okay, so that, of course, a vertical line, you'll remember, is an x-equal line, so x equals 2. So that's the equation of the vertical asymptote. Y equals 4 is the equation of this horizontal asymptote. Okay, anyways, I just wanted to show you that the asymptotes can be anywhere. It's really not a problem. Now, there's one other thing. Sometimes, especially in higher level courses, sometimes the graph will cross a horizontal asymptote. So you could get kind of a weird picture like this. Okay, so if that's the graph, or Okay, you could get something that does this, and it'll be kind of weird, but if it crosses and then does something like that, we would still consider this, or at least this part, okay, the x-axis would be a horizontal asymptote to that part. Okay, it's rare and it's kind of a weird function, but it can happen. The thing is, though, so the graph might cross the horizontal, but it will never, ever cross the vertical asymptote. It just doesn't work. Remember, a vertical asymptote happens when you divide by 0. Okay, wow, wait a sec, I haven't explained that yet, but I will here shortly. So, okay, moving on. All right, example 1. Graph the reciprocal function given the original function. Okay, so use the graph of the original function y equals f of x to graph the function y equals 1 over f of x. Okay, so now I get to start explaining a little bit. Now, if you remember, I told you earlier that y and f of x are interchangeable. So this just means y equals y. Well, that's kind of a weird thing. Okay, well then on this one, y equals 1 over f of x, well, we said f of x was y. Okay, so really the new y, okay, so the new function, sorry, I need to change my settings here, it's a little fuzzy. Sorry, there we go. Okay, so the new y value, okay, is 1 divided by, well, f of x is just y, so this is the old y value. That's what's weird. Okay, let's say that again. Okay, so y equals f of x, and now I'm going to graph some new function, some new y function, some new y graph. Okay, so f of x is the old y's. So what happens with these graphs, if I look at this graph, really all I'm doing is I'm taking the y coordinate, like let's say right here, the y coordinate is 3. So if the y coordinate is 3, y equals 3, the new y coordinate is going to be 1 over 3. Well, 1 over 3 is like probably about there somewhere, 0.33 repeating. Okay, here the y coordinate is 2. So 1 divided by 2 is 1/2. That's kind of right there. Okay, the y coordinate right here is 1. Now, you remember when things that'll be helpful, okay, we said the reciprocal of 1 is 1. So when I have my y value of 1, 1 divided by 1 is just 1. Interesting. Now look, this is where it gets kind of weird. Okay, look at the y value right there. It's 1/2, right? So the y value equals 1/2. So the reciprocal of 1/2 is just 2 over 1, or just 2. So here, at that point, the y value is 2. Remember, 1 divided by small actually gets bigger. So let's say right here, right down there, the y value is 1 over 10. Let's just say. Okay, well, the thing is, if the y value is 1 over 10, the reciprocal would be positive 10. So let's see, 4, 5, 6, 7, 8, 9, 10. So that would be way up here. So look, the graph does this. Okay, and then way out here, okay, like the graph is eventually going to get like 5, 6, 10, whatever. So way over here, see the graph? Whoa, that was awkward. Okay, so the graph goes down, gets closer and closer to the x-axis, but doesn't touch it. So there's that idea of the asymptote again. Okay, now if we do the same kind of thing on the negative side, see we're taking the y coordinates. Okay, so over here, the y coordinate is -4. 1 divided by -4 is -1/4. So that's kind of like there. Okay, now let's go to this one. The y coordinate is -2, so 1 divided by -2 is -1/2. It's about there. Okay, -1 divided by -1, okay, that's the same. It's -1. Okay, the y coordinate right about here, Okay, that's about negative 1/2. The reciprocal of negative 1/2, okay, negative 1/2. The reciprocal is negative 2/1. So that's just negative 2. Okay, the reciprocal of, see the y value there, I don't know, negative 1/10, maybe, negative 1/100th, whatever. Okay, the graph then just gets really, really big. Well, really big, but negative. So the graph just kind of rides those asymptotes. Wow, that was terrible. See if you can just draw that a little better, Mr. V. Okay, here we go. And then down, 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 down. Kind of like that. So you can see that there's a horizontal asymptote on the x-axis, and there's a vertical asymptote on the y-axis. Okay, so let's do some analysis. For both graphs, state the domain and range, okay, and the equation of any horizontal and or vertical asymptotes, as well as any invariant points. So an invariant point is a point that doesn't change between the two graphs. We'll get to those in just a minute. Okay, so the original, the domain, was x is an element of the reals. The range was y is an element of the reals. The equation of the vertical asymptote, vertical asymptote, that's the up and down line, that was this guy. That's the y-axis, which has an equation of x equals 0. Okay, the horizontal asymptote was the x-axis, which has the equation y equals 0. Okay, now we skipped invariant points because they're going to put them in the middle. You'll see why in a sec. So the domain here was x cannot equal, or x is an element of the reals, but x cannot equal 0. Wow, that's really embarrassing. I'm so sorry, we're backing up. On this original graph, remember, there's no vertical asymptote on the red line up here, right? That just goes on forever. So there's no asymptote. There's nothing we get close to and don't touch. Okay, the horizontal asymptote, there's none of those either. Okay, wow, that was awkward. I'm sorry. Okay, so there's no vertical or horizontal asymptote for the red line. Okay, the domain for, so back to here to the reciprocal graph, the one I drew in blue. Okay, so x is an element to the reals, but I can't equal 0. The range is y is an element to the reals, but I can't equal 0 there either. Okay, the vertical asymptote, now we have a vertical asymptote. I have a line that I get close to but never touch, right? This is going to go down forever. Okay, and never touch that y-axis. So the equation of the vertical asymptote is the y-axis, or x equals 0. Okay, the horizontal asymptote is the y or x-axis, so that's the equation y equals 0. Now, invariant points. When we talked about, or when we got these points, we just took 1 divided by the y-coordinate. See, remember, here I'm going to draw in orange so you can see it better. This point didn't move, okay, and neither did that point. Okay, that when I drew the new graph, I drew it right on top of the old one. Okay, and that's because the reciprocal, when y is 1, the reciprocal of 1 is 1. The reciprocal of negative 1 is negative 1. So those points don't change. Okay, so look, this point, that how always happens when y is negative 1 or when y is positive 1. Okay, and then the x values are just what they are. Well, in this case, the x value, okay, is positive 1 when the y value is positive 1. Okay, and we get negative 1 and negative 1. So those are our two invariant points. Awesome. Okay, so summary of the reciprocal function y equals x. Okay, so we have y equals x, y equals 1 over x. Okay, now the domain, of course, x is an element to the reals, y is an element to the reals. Okay, these ones Okay, x is an element of the reals, but x can't be 0. So there's one exception. So it's everything but 0. For the range, 1 over x, the reciprocal function is y is everything except 0. Y cannot equal 0. Okay, the end behavior. Okay, remember, so this is the formal way of saying, okay, if x is positive and absolute x is very large, okay, all that means is it's very big. Okay, so if we go 1 divided by very big, okay, that's very large. Okay, and then 1 divided by very small, okay, this is the negative version. Okay, if x is less than 0, so x is negative, and absolute x is very large, okay, then y is less than 0 and is very big. Okay, that's how that works. Now, right, because this is just y is equal to x. Okay, in this one, okay, we say when x is bigger than 0, and absolute x is very large, so now we're going 1 divided by. Okay, so 1 divided by very large is very small. So y is still bigger than 0, but it's very close to 0. 1 divided by big is small. Okay, here when x is less than 0, so negative, but the absolute is very large, so basically negative and large, okay, then what we get is y is less than 0, so still negative, but it's very close to 0. So 1 divided by big is very small. Okay, so the end behavior at x equals 0. So here, y equals 0, right? But then 1 divided by 0, right? If x is 0, 1 divided by 0, okay, that's undefined. So that's where the vertical asymptotes happen, whenever this bottom equals 0. So in this case, 1 over x, well, that we divide by 0 when x equals 0. That's why there's the vertical asymptote there. Okay, and then the invariant points always happen when the y values are either 1 or negative 1. So if the y values are negative 1, we'll look at this. Negative 1, that has to equal x. Well, then x equals negative 1. Okay, if y is positive 1, well, that equals x, so x is positive 1. Interesting. Okay. So, example 2. Consider the function, okay, f of x equals 2x plus 4. Sketch the graphs of y equals f of x and its reciprocal function, y equals 1 over f of x. And for both graphs, state the domain range equation of any asymptotes, horizontal or vertical, as well as the coordinates of any invariant points. Okay, so we got a graph 2x plus 4. Okay, and then, because that's f of x, and then I have to graph y equals 1 over 2x plus 4. Whew, okay, well, we can do this. Okay, so 2x plus 4. Remember, that is a y-intercept, 1, 2, 3, 4. Okay, so that 4 is the y-intercept. This is more from grade 10. And then slope is positive 2. Now remember, 2 is a fraction. That's 2 over 1. Remember, slope is rise over run. So I start at my y-intercept, and I go up 2, okay, rise of 2, and over to the right 1. Okay, now I can make a line from there, or I can make some more points. Now look, my graph, I'm at the edge of the graph here. So remember, with slope, you can also go down 2, and left 1. That still equals a slope of positive 2. So down 2, left 1, down 2, left 1, down 2, left. Oh yeah, look, I can get a lot more points this way. So this that's the equation y equals f of x, or y equals 2x plus 4. Okay, so now to get the reciprocal, here's how we do this, and it's kind of neat. I'm going to draw in blue for a second. Okay, look at this point right here. The y coordinate is 0. So that's when this part is 0, so you get 1 over 0. That's never allowed, so this is where the vertical asymptote happens. And we just draw it with a dotted line. It's great. Okay, so now we start doing some graphing. Like, look at this point. Okay, y equals 2. So the reciprocal of that is 1/2. Okay, right here, the y value is 4, so the reciprocal is 1 over 4. So that's like a quarter kind of down there. Okay, now look, this is harder to see, but look right here. The y value is 1. So the reciprocal of 1 is 1. So that's great. Now, this is really hard to see, but in here, see how the y values are getting closer and closer to 0? So let's try this one. Like, that's, I don't know what that is, like 1/10, 1/5, like whatever. Okay, it's really small. But 1 divided by really small is really big. So if I say that it's 1/5, just imagine that that point is 1/5. The reciprocal of that is 5. So 1, 2, 3, 4, 5. Okay, so the graph kind of looks like that. And it does this swoop thing. Okay, and we go all the way down, and we basically follow the x axis all the way down, and then this line all the way up. Okay, now we do the same thing with over on the negative side. Okay, so look, this guy here is -6. So 1 over -6 is -1/6. So it's really small, but it's negative. Okay, so it's on this side it's underneath the x-axis, but it's really, really small. So this one's -4, so then we have -1/4. Okay, this one is -2, so it's going to be -1/2. Okay, this one, that point is -1. The y value is -1. So the reciprocal of -1 is -1, so that one stays the same. Okay, and then we do the same thing. These ones, the y values are very small, like down in here. So the reciprocal is going to be 1 over very small, which is very big. So the graph kind of swoops and follows the asymptote. Okay, and then swoops back this way and follows the asymptote. Great. So that's how you draw these things given the graph. Now, the domain of the original, remember, is x is an element of the reals. The range is y is an element of the reals. The orange line there goes on forever, sideways and up and down. Okay, so there is no asymptotes for that graph. For that orange graph, we just keep going on forever. We don't get closer to anything. Okay, it just keeps getting bigger and bigger and bigger. Okay, for the reciprocal, the blue graph though, the domain is everything except x can't be. Now our previous example was x couldn't be 0, but this time x can't be 1, so -1, -2. X can't be -2. Awesome. The range is y is an element of the reals, except y can't be, well here, it's still the x-axis, so y can't be 0. Okay, the equation of the vertical asymptote, okay, is x equals -2. That's the vertical line passing through, x is -2. And the horizontal asymptote was still y equals 0, or the x-axis. Okay, invariant points. So invariant points, I'll circle. There's one right there. There's the other one. Interesting. So this happens when y equals -1 or y equals +1. This is harder to see, right? I mean, the last example was easy because it was just 1 and 1. This one's a little trickier. So we go back up to the equation. Remember, y equals 2x plus 4. So y equals 2x plus 4. Awesome. So the thing is, if the y value is -1, so -1, equals 2x plus 4. Oh, interesting. Okay, so we do some algebra here. So minus 4 minus 4. So negative 5 equals 2x divided by 2 divided by 2. So that's negative 5 halves, or negative 2.5. So that's what the x is. So negative 5 halves and negative 1. Now 5 halves, did I do that right? I think so. Negative 2, so that's negative 5 divided by 2. So remember, that's negative 2.5 and negative 1. There we go. So does this point look like it could be negative 2.5? So let's see. Negative 1, negative 2. Oh yeah, negative 2.5 and negative 1. Yeah, that makes sense. Okay, so that's one of our invariant points. I'll write it once with fractions and once with decimals. Okay, now the other one was when y equaled positive 1. So we just use that same equation, and we go y, so 1 equals 2x plus 4. Okay, so this time it's positive 1, not negative 1. So we go minus 4 minus 4. This time it's negative 3 equals 2x divided by 2 divided by 2. So then x equals negative 3 halves, which is negative 1.5. Let's see if that makes sense. So when the x value is, oh, look at that. It's like negative 1. Oh, negative 1.5 would be there. Okay, so negative 3 halves and positive 1, or negative 1.5. Sorry. Negative 1.5 and positive 1, if we want to use decimals. Now, if you use your graphing calculator, the invariant points will always be the intersection of those. So on the TI-84, you can go second calc, intersection, and find those two coordinates. Or on the TI-Inspire, you can use your menu, analyze graph, and then intersection. Okay, and you can get those 2 points that way. So you can either do it algebraically like I did, or graph them on your calculator and find those intersections. Whew. Okay, last one. Okay, so example 3. You can model the swinging motion of a pendulum using many mathematical rules. For example, the frequency, f, or the number of vibrations per second of one swing, in hertz, equals the reciprocal of the period, t, in seconds of the swing. Whew, wow, that's a mouthful. Basically, the formula for this is frequency is 1 over period. Okay, not a big deal. Frequency, that's the number of vibrations per second. Okay, and t is the time for one swing. All right, so the formula is f equals 1 over t. Okay, so sketch the graph of this. Well, remember, we don't graph f's and t's. We usually graph y's and x's. Hey, we've already seen this equation before. Okay, so that is, okay, so the invariant point was 1, 1 and 1, negative 1. Okay, so if you graph this 1 over x on your graphing calculator, you'll get it too, but it looks like this. Okay. Wow, that's not a great drawing, but that's close enough. Okay, so it kind of does the swoop thing, and those are your invariant points, 1, 1, and negative 1, negative 1. Okay, so there's a quick sketch of that. What is the reciprocal function? Well, hey, if the function is 1 over t, then the reciprocal is just y equals t. Okay, fair enough. That's great. Now, determine the frequency of a pendulum with a period of 2.5 seconds. So frequency is 1 over period, which is 1 over 2.5. Oh, okay. Well, we just type that in. Okay, so 1 divided by 2.5. Hey, that's 0.4. 0.4, and the units on frequency are hertz, Hz. Okay, so that's the answer for that one. Okay, and then what is the period of a pendulum with a frequency of 1.6? So frequency is 1 over period. So 1.6 hertz equals 1 over t. Okay, now there's lots of different ways of thinking of this. We can go over 1 and cross multiply and divide. Basically, when we do that, what happens is the t and the 1.6 actually trade places. Okay, so we can go t equals 1 divided by 1.6 hertz. Okay, that's how we can find the period. So 1 divided by 1.6 is 0.625. Now the t is measured in seconds. So 0.625 seconds. So there you have it. So everybody, I would like you to please practice this material. Okay, it is section 7.4 in your textbook, starting on page 403. So I want you to try these numbers. Okay, these are all linear functions. Okay, so you can just use your textbook, or we have also printed this document, these textbook pages, and attach them to the workspace card, so you can just print them off right from there. Then you can write all over the page. So anyways, thanks for watching, and we'll see you next video. Thanks.